The empirical formula of a compound is the simplest whole number ratio of atoms in that compound. This may or may not be the same as the molecular formula of the compound, which we'll talk about after we learn to calculate the empirical formula. So let's take a look at an example. Vitamin C has the mass composition 40.92% carbon, 4.5% hydrogen, and 54.5% oxygen. And it's important that we specify that it's by mass, or that this is the mass composition, because we're going to use grams to convert to moles. We want to know what the empirical formula of vitamin C is based on this percent mass composition data. So first thing we do is a little trick, kind of a trick that says basically if we had a sample that contained 100 grams of vitamin C, then these percentages would be the amount of grams of each atom in that sample. So we can just write the percentages as grams if we had a 100 gram sample. So if we had a 100 gram sample, then 40.92 grams of that sample would be carbon, and 4.58 grams would be hydrogen. And then we would also have 54.5 grams of oxygen. So that's the first step. And then the next step is to convert all of these into moles. So we take the grams, we convert to moles, right? You divide by the molar mass. So carbon has a molar mass of 12.01 grams. That's 1 mole of carbon. Hydrogen, 1.01 grams is 1 mole. And for oxygen, its molar mass is 16 grams per mole. So we convert each of those to moles, and don't worry about significant figures in these problems because we're going to end up with a formula. So you won't have any digits in your final answer. It'll be a counted number. We're looking for the whole number ratio. So the number of moles of carbon in this sample is 3.40716, and it's a good idea to not round at this early point in this problem. We have 4.53465 moles of hydrogen, and for oxygen we have 3.40625. Okay, so now that we've converted to moles, we can find the ratio. So the thing that you want to do here, and this is usually referred to as the third step, divide by the smallest number of moles. And so from this point on, if you do anything to one of these quantities, you have to do the same thing to each one. So let's divide by the smallest one. Divide all of those by 3.406. Let's divide by the number of moles of oxygen. So 3.40625 moles for each of those. And obviously oxygen is going to be 1. So we have 1 oxygen in this preliminary formula. We also have 1 carbon in this preliminary formula. And then for hydrogen, we have 1.33 hydrogens. So we can write a preliminary formula, C1 H1.33O1. And remember, we're looking for the smallest whole number ratio of atoms in the compound. So we're going to have to multiply this by some factor to make this a whole number. And so if we multiply 1.33 by 3, we'll get 3.99. We can just round that up to 4. So we multiply these all by 3. And our empirical formula is then C3 H4O3. So that is our empirical formula for vitamin C. And so now, how do we find the molecular formula now that we've got the empirical formula? Well, the empirical formula is always the first step. The molecular formula is the actual ratio of atoms in a compound. Sometimes this could be the same as the empirical formula. And basically the question we want to ask here is, how many empirical formulas are contained in the molecular formula? And so the first thing we want to do is calculate the molar mass of the empirical formula. And for this one, if you add up 3 carbons, 4 hydrogens, and 3 oxygens, you get 88.07 grams per mole. And you would have to have the molar mass of vitamin C to solve this problem. And so that is usually given in the problem. So vitamin C has a molar mass of 176.12 grams per mole. And so the way to find out how many empirical formulas you have in the molecular formula is to divide the molecular formula's molar mass by the empirical formula's molar mass. So divide 176 by 88, and you get a factor of 2. So it's 1.999. So let's call that 2. And so we multiply the empirical formula by 2. So C3, H4, multiply all of those subscripts by 2, and the molecular formula is C6, H8, O6. So that is the molecular formula of vitamin C.